All right, today we're looking at shell method, which is a method that is not tested by name on the AP exam, but is still really good to look at. So shell method, unlike disk, where we're revolving a single slice that's infinitely thin to create a tiny disk, we're instead going to be revolving a vertical slice around a vertical line to create a shell. We call these nested shells. If you think about it, the idea is if you take a like dollar bill or something and wrap it in a circle, it now becomes a shell of what you had. And we're going to use that concept of a rectangle that is wrapped into a circle more. So the idea here is we're taking a single rectangle and revolving them, and we're going to take an infinitely small rectangle and revolve an infinite number of those rectangles to create this. All right? Now, notice how it creates this kind of shell there instead of the disk we have been having. Okay, so if we looked at all of them, we would end up with these nested shells, these shells wrapped around each other as we look. Okay, so let's talk about the functionality of this. So let's take that same picture we had, where we have the square root function and a single shell here. Oops. Okay, so this is an infinitely thin slice that is being revolved into 3D space to create this shell. Okay, that's what we're creating. Now, I want to imagine you take this revolution and break it open into a rectangle. So that dollar bill that we're thinking about that's been wrapped up, we're breaking into a rectangle. Well, the height of this rectangle is the height of whatever slice we're using. All right, so in this case, that would be the function. But sometimes, in other cases, it might be like function 1 minus function 2. It's whatever the height of this slice is. Now, the width here, okay, this is going to be the circumference of this cylinder we've created. So circumference of the cylinder is the circumference of the circle. So it's going to be 2 pi r. Well, we need to figure out what that r is. Well, if we look, the r, here's our axis. The r is just how far we are from that axis. In other words, it's just our x value. It's the x value. So it's 2 pi x. Really, it's 2 pi x minus the axis. Okay? And so h is just our function. Sometimes it's function minus function. Y, or the r is our x. Sometimes it's x minus the axis. In this case, the axis was 0. But now, what does this do for us? It does a few things. The big thing is, if you look, our slice is still perpendicular to the x-axis, which means we're still using it in terms of x, but it's revolving around a y-axis. That's huge for us, because in previous problems, if we wanted to revolve around a vertical axis, we had to change it in terms of y. Now we can leave it in terms of x. So any of those problems, maybe like one we've seen before, where we had 2 separate functions and had to split it in half, because we had to keep it in terms of y and our slices had to go this way. Well, now we could use a shell, keep our slice this way, and never have to change it in terms of y, and never have to split that integral into 2 integrals. This is huge what shells lets us do. We could also change it in terms of y, do our slice this way, and revolve around this axis, if we wanted to. Not always going to be easier that way, but that is an option. So let's look at our problem. For this one, we have square root of x, x equals 4, and y equals 0, revolving around the y-axis. So that's just the shape we just had. Okay, x equals 4. Okay, y equals 0 is this right here. And here's our square root function. So let's draw our one slice. Boom, there's our one slice. We'll revolve it. Oops. Excuse me. Okay, and we want to break this open. So this is one thing I want to see every time. I want to see you break it open into a rectangle every single time. break it open. So our height, if we look, it's going to be this distance right here. That's our height. Well, that's just square root of x minus 0. So square root of x is our height. Our radius, or our width, is always going to be 2 pi, and then our radius. Okay, 2 pi, and then our radius. And we said our radius is either x or x minus the axis is more accurate. Well, so in this case, it's going to be x minus, and then our axis revolving around is this one right here, so x minus 0. Now, one thing I didn't say is what we're actually going to do with this. We're going to do the same thing we've been doing. We're going to integrate on the interval of this area function. Okay, this is the area of one slice. We're going to do integral across multiple areas. So we have the integral from 0 to 4 of 2 pi and then x square root of x dx. And this is one we could do by hand. We just got to actually combine it. And we integrate. Now, if you go back to what we did yesterday, or at this point, it was a week ago now. If you go back to when we did disk and washer and revolved around the y-axis, you'll see this gives us the same answer. Okay, we get the same exact volume because we're going around the same axis and we're doing the same shape around that axis. It's just now we're doing it by getting a different type of slice. All right, let's look at this one. X minus x cubed and y equals 0. Okay, we can figure out where they intersect. They intersect at 0 and -1 and +1. Yeah, 0, -1, and +1. So we have an intersection here and an intersection here at 1. And we're not going to worry about the -1 because it didn't tell us to. So we're going to have something like this. And we want to revolve around the y-axis. Now, this is the other big reason why shells is so important. This is a problem you would never actually see on the AP exam because it cannot be done without shells. If you have tried to write or do a slice this way, notice your upper function and your lower function, your outer and inner radius, are going to be the same function. There's no way to get it written properly. That's because it's not actually a function when you look at it that way. If you switch it, it's no longer a function. It fails the vertical line test in that case. All right? So we're going to have to use shells. We create our vertical slice here. We revolve it. Okay, we have this shape right here. We're going to break it open into our rectangle. The height of the rectangle is going to be this height right here, which is the height of that function. So that's just going to be x minus x cubed. The the width is going to be 2 pi and then our r. R in this case, our axis is still the y-axis, so it's just going to be x minus 0. And we do 2 pi, integral from 0 to 1 of x times x minus x cubed. Or in other words, x squared minus x to the 4th. There we go. Okay, let's see. Let's do, let's do this one right here. Let's do this one. So the last one we're going to look at is one where the axis is not 0. So we have x squared, y equals 1, and x equals 0. So we'll say y equals 1, x equals 0 is this right here. So that means this section right here is our slice. We're revolving around x equals 2. Well, x equals 2 is over here. There's 1, there's 2. This is what we're revolving around. Okay? And this is where saying x minus the axis is a little problematic. And let me explain real quick. So we have our revolution. Here's our slice. It's really ugly, but bear with me. All right, we'll break it open into a rectangle. Our height is going to be this height right here. Well, that height is 1 to the function. Okay, that's going to be that height. So we have 1 minus x squared is our height. Our width is still 2 pi r, but this time our r, this is our axis 2. to x. So we need the distance from the axis to x. So saying x minus the axis wasn't great. It's the distance from the axis to x, or x to the axis. Well, to get that, all of our x's here in this shaded area here, all of those are going to be smaller than the axis. So to come out with a positive value, we actually have to do 2 minus x, the axis minus x. And then when we set it up, we have 2 pi, integral from 0 to 1, of 2 minus x times 1 minus x squared dx. And this would be our volume formula for this one. Okay? All right, that's it. Let me know if you have any questions. You'll have a great